It's fairly common to solve inequalities by algebraic methods. And so if we have an inequality that looks like this, we've got a greater than or equal to sign, we can solve it by isolating the x. So we've got x's on two sides. We're going to get rid of the negative x by adding x to both sides. So we have over here 3x minus 2 is greater than or equal to positive 4. And adding the 2 to both sides, we get that 3x is greater than or equal to 6. And then dividing by 3, we end up with positive x is greater than or equal to 2. And we can write this in either set builder or interval notation, set builder notation. We're going to write the set of x's such that x is greater than or equal to positive 2. And in interval notation, if we drew a graph where we had 2 as the dividing point and greater than is shaded on the right hand side, we'd have something that looks like this, and then the endpoint, which is a greater than or equal to, would be written as a square bracket because that endpoint is included, and so the interval would look something like the graph where the lower boundary is at positive 2 and it goes up to positive infinity. So that is the interval from positive 2 to infinity, including the point at 2. So that would be the algebraic way of solving this inequality. But we can also solve this same inequality graphically, and so we're going to take a look at this example, which is essentially the same inequality. But what we've done is deconstructed the two parts, the left-hand side and the right-hand side, into two separate functions. So the first function is the left-hand side, which is 2x minus 2, and the right-hand side is g of x, which is negative x plus 4. And the first thing that asks us to do is to graph both of these functions on the same graph. So let's go ahead and do that. And the first function is f of x is equal to 2x minus 2. So we can plot the y-intercept at negative 2, and for the slope of positive 2, that means 2 up for every 1 to the right, and we can then graph the line. So this pink line represents our function f of x is equal to 2x minus 2. Next, we want to take a look at g of x. So here we've got our g of x function, which I'll write down here. We have g of x is equal to negative x plus 4. And again, we can think of this as a line where g of x is equal to y, and the slope is equal to negative 1. And you can think of that as being negative 1 divided by 1, and the y-intercept is at positive 4. So we will graph that y-intercept on the y-axis at positive 4, and a slope of negative 1 means we go 1 down for every 1 to the right. And we can plot these points and draw our line accordingly. So the function g of x is represented by this green line here. Now what I want to do is take a look at the questions which say find the value or values of x where f of x is equal to g of x. And for these two functions to be equal, we're looking at the point of intersection. So we can circle that point there, and that will be that value or the solution of the system. And if we want to look for the coordinates, the x value, as we drop a plumb line down to the axis, we can see that the value on the x-axis is 2. So our x value is equal to 2, and that does answer the question. However, if we wanted to give the ordered pair coordinates, the x-coordinate would be 2, and then the y-coordinate if we extend over to the y-axis, we can see that value is also positive 2, and so our solution of this set of two equations would be 2, 2. Next, we're asked to find the value or values of x where f of x is greater than or equal to g of x. So now we're not only concerned at the point of equality, but we actually want to see also where f of x is greater than g of x. If we think of f of x as being the purple or the pink line, and greater than means having a higher y value than g of x, which is the green line, we can see that the pink line lies above the green line in this region here. And that begins at 2 but extends for those values that are greater than 2. And so the value or values where f of x is greater than g of x, the x values, are again when x is either greater than or equal to positive 2. And we can write this in set builder notation. Values of x, set of all values of x such that x is greater than or equal to positive 2. And if we kind of imagine this as being a number line here and the values extending above 2, we can say that this interval begins at the point positive 2 with a square bracket because it includes that point and goes up to positive infinity. And if we compare our graphical answer with our algebraic answer, you can see that we get the same thing. And so this is just an alternative way of graphing inequalities.